All right. So today we're going to do 5-2, which is called direct variation, okay? And it is a version of a linear function is the first thing I need you guys to realize, okay? So normally we do y equal mx plus b, right? And that was what we did for linear functions. Well, direct variation is a version of that, but they call it y equal kx, which I wrote right on here. Okay? And k is the rate or the slope, just like it would be mx. What they want us to realize, though, in direct variation, the y-intercept, notice there's no plus b. It's because it's 0. So anytime there's like a direct variation, your y-intercept is technically 0, okay? And so that's, and then for whatever reason to distinguish, they call the constant of variation k instead of calling it the m or the slope. So it's pretty easy to understand if you realize that this is very similar to using the y equal mx plus b. All right, so they're just naming it some different things, and yeah, kind of the key here is that your y-intercept has to be 0 in order for it to be a direct variation. Okay, so we have 3 examples that I want to show you today. The first one is, does each equation represent a direct variation? If so, find the constant of variation. So the way you do this is you get it to say y equals, just like we practiced a little bit yesterday. And then not only do you have to do that, you have to check to see if your y-intercept is 0 or not, or if there's one present. So if you take a look at this first question, to get that to be y equals, what would we have to do? What would we have to do? Alvin, go ahead.
Divide 7 by 7.
Yeah, exactly. All right. And so we're going to divide by 7 here to get rid of it, or to cancel it out. And we divide by 7 here. And so you get y equals 2 over 7x. Okay, so to decide whether or not this is direct variation, what is the y-intercept here? Is there one?
Yeah.
What is it?
2 over 7.
Nope, that's the rate. What's the y-intercept?
0.
It's 0, okay? So check. The y-intercept is 0, so that's good. That means we have a direct variation. So this is, does it represent direct variation? Yes. And your constant of variation, that they call k, is our slope. So that's the 2 over 7. That's what that means. Okay, does that make sense? Ooh, let's make sure I'm on screen here. Yep, I am. Okay, good. All right, let's do it again. So the second one, 3y plus 4x equal 8. So step 1 is to get y alone, like we kind of practiced yesterday. So if you're looking at this, remember we start with the one. 8 is already on the other side. We're not worried about that one, but we start by undoing the part that's furthest away from y. We're undoing PEMDAS. So the first thing we're going to do is undo a plus 4x. So you want to subtract it. Minus 4x to cancel it, and minus 4x over here. Now y has to be alone, so you have to get rid of the 3 as well. What do you have to do to get rid of the 3? Or cancel out the 3, I should say. Emma, go ahead. Perfect. Divide by 3. Divide each of these terms by 3. Okay, and now you want to rewrite it. So y equals 8 divided by 3 doesn't divide into anything other than a decimal, so we'll leave it. And then same with 4 over 3, so minus 4 over 3x. Okay, so to check if it's a constant or if it's a direct variation, is the y-intercept 0? It is not. What is the y-intercept?
8.
Go ahead, Donovan.
8 over 3.
8 over 3. So this is our slope or our constant, right, is negative 4/3. Since there's this extra one there, this one is not a direct variation, okay? So this is a no, not direct variation. It's still linear, It's just not a direct variation. Okay? So there's a difference. All direct variation is linear, but they go through 0, 0. Okay? So there are linear functions that are not direct variations. That's what that means. All right, let's do this. Example 2. Let's make sure I'm on screen again. Okay, example 2. Suppose y varies directly with x. So that means that there's going to be y equals your, whatever your rate is, x, and no y-intercept, or y-intercept of 0. And y equals 35 when x equals 5. What direct variation equation relates x and y? What is the value of y when x is 9? Here's how you set this up. Since you know that it's direct variation, you know it's going to be y equals kx, right? That's how you start. That's the general format of direct variation. Then you put in the information given. So y, they tell you, is 35, and x is 5. So we're going to replace y with 35. We're going to replace x with 5. And we're going to leave k in there. And remember, that means times. They're right next to each other. So the first thing we have to do is solve for our rate, right? Our k, our constant. How do I do that? What do I do to solve for k? Emma, go ahead. I divide by 5. That's right. So if I divide this 5 out of here and divide over here, our constant of direct variation, 35 divided by 5, is 7. So our rate is 7. That's the first thing you need to find out. So to write the equation now you go back to this original format. Our equation is y equals 7x. That's the equation. So step 1 is to solve to figure out your rate. Okay, so we just answered our first question. And our second question now is, okay, what is the value of y when x is 9? So what you do for the second part is you substitute in what they give you into your equation. So if x is 9, we times that by 7, and we're going to get our answer for y. So 7 times 9 is what?
63.
63. So the value of y when x is 9, y equals 63. That's our second part of our answer. Okay, so these questions and on a test, they give 2 questions really in one, right? The equation is your first answer, and then when you substitute in to get an answer, that's your second answer. All right, last one is to do this with a real life example here, okay? And this one is actually, it's out of our textbook, but it's actual data here. So weight on Mars varies directly. You're going to see that. You'll probably notice that when you read some of these now. Varies directly with the weight on Earth, meaning it's going to make that form, y equals the constant times x. The weight of a science instrument called the Phoenix Mars lander on Earth is 130 pounds, and on Mars is 50 pounds. What is an equation that relates the weight in pounds on Earth, x, and the weight on Mars, y? Graph the equation. Okay, so you're going to use the same process as before. So you're going to start with y equal kx, which we did up here, because it tells us, the reason we know that is it said varies directly. So that's how you know you're going to use that format. Okay, what information is given that I can put into that to solve for k? Like, you got to look through there, and then you got to know what one is what, too, okay? Elvin, what do you think?
X is 130 and y is 50.
Yes, and that's right. How did you know which one was x and which one was y?
Because Earth is X and Mars is Y.
Yeah, it tells you Earth is x, Mars is y, and it tells you up here Earth is 130 and Mars is 50. So when Earth is, so we're going to make this one 130 for x times k equal, and then our y value is 50. Okay, so how do I solve for the constant of variation now. What do I do to solve for k now? Somebody on this side, what do I do to solve for k? Go, Emin. What do we do? Yeah, divide by 130. Now, this gets confusing, right? Because you're like, well, that's going to give me a decimal. So let's leave it a fraction, but simplify the fraction. So if you have 50 over 130, if you simplify that fraction as far as it can go, what's the simplified version? 50 over 130. Simplify. This one should be an easy one. They both end in 0. Kim, what do you got? Yeah, 5 over 13 is our k, or our constant of variation, okay? Okay, so that's not really either one of our answers. Our first answer was to write an equation. So what does the equation look like now? So I'm going to do that up over here. So our equation is what? This is what we did up here for our last one. So write me the equation. Cody, go. 5 over 13, you mean? Yeah, 5 over 13x. That's our first part, writing the equation. You solve for the constant here. Now the first question is to write it in this format. Okay, now the second part says to graph this equation. Okay, how would you graph the equation? Emma, what do you do?
I found this on the web.
Oh, Suri knows how to do it. Okay, so you can use your graphing calculator. You can also do this kind of in your mind, okay? So make a small graph like this, all right? And our x values, right? What did it tell us our x values are? Earth, our weight in pounds on Earth. Weight. And our y values as our weight on Mars, right? Okay, so this spot right here is 0, 0, right? So if x is 0, y is 0, isn't it? Now, what I would do is I'd use your graphing calculator, I'd put that in the y, right? And I'd use the table after that. So use your graphing calculator, and mine is, oh yeah, Donovan, do you have mine? Or you found yours?
No, it's just chicken.
Oh. Okay. Oh, mine doesn't have any batteries in it, of course.
Oh, I didn't bring mine. I want mine.
Okay, so I'm going to use somebody else's real quick. Thank you. All right, so on here, well, you want to make sure you graph this equation, okay? So y equals, we'll clear this out, 5 divided by 13 times x is what we really have. So when you put that in, that's what you want to make sure you've got on there. 5 divided by 13 times x. To make sure you got everything right, put that fraction in parentheses. Now, of course you can graph it, right? But what we want to do to make sure the graph is correct on here, go to the table. And so it's hard because 1 pound on Earth is equal to 0.38462 pounds on Mars. That's really hard to graph. So what you want to do is scroll down until you can get to some whole numbers. Here's your first whole number, right? When x is 13, y is 5, right? So 13 pounds on Earth is equal to how many pounds on Mars? 5. So that tells you, this is going to tell you the scale that you should go by. The x's, we're going to go by 13s. I know it sounds like a weird number, but every 13 is going to go up 5. It'll be nice and easy to graph, okay? So let's do that. So we're going to go 13. 26, 39, okay? And you can keep going and going and going. I'm only going to do the first 3. So on here, what would I go by on Mars? 5s, yeah. 5, 10, 15. And if you're not sure, you can double check your answers. This will go all the way down, right? And you can double check all of your ordered pairs. So here's 39 and 15. And then you put your dots on. This is going to be a linear function. Okay? And draw your line through. Because of course you can be pounds in between 13 and 26 and stuff like that. Okay, so that is the basic lesson. Are there any questions on the lesson so far today? Okay, for people who are not here and are listening to the video, the homework today is going to be 5-2 practice, but we are only going to do the even numbers on 5-2. Okay, even numbers on 5-2. For everybody who's here, I hope that you grab that on your way in, and we will do some of these together.